I'm up in Danby with Derek Cornell of Big Wind and Solar, and we are here at a house that is off the grid. It's got, well, I'll let Derek tell us.
Okay, well, we've got a 80-foot, 1,000-watt wind turbine up there, and we have 1,700 watts of solar panels, as you can see behind me here. These all feed in, are producing power to the batteries, which we are storing to be used, we converted into regular AC power for the house and their needs. The solar seems to take care of most of the needs in the summer, and the wind supplements in the winter. Both together is even better. So, as the wind picks up, the tail section will actually bend away from the main generator unit. This one actually lifts up and away from it. Sometimes you think it would be falling off the way it looks, but it's just reducing the power the wind is interfacing to reduce the power.
Why?
You don't want overproduction because it doesn't do any good. You know, once it gets up there above 30, you want to start turning out of the wind before you do damage to it or whatever. So it will survive up to 100 mile an hour wind, they say.
How much power does the wind put out at optimum?
The optimum power is 1,000 watts at about 25 miles an hour. It takes quite a bit on a small wind turbine like this to produce some reasonable power.
And the solar?
The solar, less clouds, no snow, that all helps, But we put out about 1,700 watts per hour off this array here. So in the winter we're putting out a little over 3,500 watts a day.
Which is enough for an average family of four to use in a day?
Off-grid you do have to learn to use your power wisely because of, you're limited by what you can draw off it, so you have to make sure all your appliances and everything else are sized accordingly to use the least amount of power. You can always supplement with more panels, bigger turbines or whatever, but then you're sort of, losing the whole idea of being off-grid, saving money, using less power, even though you're making your own.
And to invest in something like this, can you give us a rough idea of what it would cost?
Off-grid tends to be a little more expensive because of batteries and all the controls we have to install. Grid tied, we're looking at usually around $5 to $6 a watt installed. Wind, we're up to, grid tied would be up around $8 a watt installed, or higher depending on the site and such. Off-grid, we tend to be about, this was about $8.50 a watt installed here. So that is on the, but the average is a little higher than that.
And the lifespan, I mean, will it pay itself off in some day down the road?
In this particular location, it's all they had available to them without spending a lot of money bringing power down in. And at that point, they decided it was a better choice for them, the environment and everything else, to go this way instead of going to CV or whatever. Okay. It'll pay them back within probably 10 years. The average is about a 10 to 12, 13-year payback in any of these systems. Some of the other hot water's a little less and such, but most of the systems are in that payback too.
And what kind of maintenance is involved here?
Every couple of years, you just check, you check the turbine once a year with binoculars and the wiring and such like that. Every 5 years, you should drop it down and take a look at it, paint it, grease it, or whatever it needs. They don't, and check the wiring in it, and that's about it. The solar panels, you clean them and check wiring. The batteries are the biggest thing on off-grid. They do have to be maintained, checked, every week or two for water level and charging and all that. But it's not a big deal. It's just, something you learn to live with, and it's part of it.
It's fascinating.
So they're very happy with it. I've got 4 other customers off-grid, and it works very well.
Can we go look at the batteries?
Yes, why don't we do that?
Okay.
We're on the back side of the building here. All the controls and inversion and battery storage takes place out here, being there's not room inside. Besides, the battery shouldn't be stored in a living area. You can hear and you see we have a fan running, which removes the vapors from the battery storage area. This up here, the white unit here, would be your inverter and charger. This over here is a solar and charger. Which actually takes the power from the solar cells, mods, converts it and charges the batteries. This over here would be the wind turbine controller and charger, which regulates that. It's a usage meter telling you how much the people are using in the house, so we can compare usage to need, draw. In case there's a problem in there, we can determine where that might help us determine this.
I would assume, I see they have a chimney, so they have a fireplace.
They have a fireplace, and they back up with gas here.
Okay.
The little they use, they have a gas refrigerator and electric. When they're here, they usually run it on electric whenever they can, because it's more efficient. And they do a little bit of heat with gas. Keep the bathroom warm when they're not here in plumbing.
Makes sense.
These are the remote controls for the inverter and the wind turbine and the generator start. From this controller here, you can set your charging rates, your amperage, you can see what's going on, make changes, shut it off, such and such. Same thing goes on with the wind turbine down here. We have production in here, what it's outputting, how much a day it's making and such. You can shut it off here and do a few other things. Most of this stuff doesn't get touched once it's set. But if need be, it's right here at your fingertips without having to go outside and get into the shed.
Thank you, Derek. It was very nice to meet you, and it's just fascinating.
Thank you, Kathy. I'm glad I get to be a help and show you what's going on in the world of green and energy efficiency. So, thank you.